In this revision session, we're going to look at the 2009 January past paper, and we will be doing question 9 only. So let's go to question 9. So in this section, you're required to do question 9A and then B. So let's look at part 9A. You're asked to make T the subject of the formula from what is given there. So we have P over 2 equals to the square root of T plus R over G. First thing is square both sides of the equation to get rid of the square root sign. So on the left hand side I need to square that side, and on the right hand side I need to square that as well. So what we get is P squared over 4, and on the right hand side I just get T plus R over G. We multiply both sides by G, so we get G P squared over 4 equals T plus R. We want to make T the subject of the formula, so we take R both sides. So on the right hand side we get T, and then on the left hand side we get G P squared over 4 minus R. So we have found T. Let's move to part B1 of the question. So here you have 2x squared. So we have f of x equals to 2x squared minus 4x minus 13, and you're required to write it in the form f of x is equal to a into x plus h all squared plus k. So we're going to write 2x squared minus 4x minus 13. We want to express it into the form that is identical to a into x plus h all squared plus k. So we're going to do everything on the left hand side and make it equivalent to this, and then we can determine the values. So we divide both sides, divide throughout this by 2. So we have 2 into x squared minus 2x minus 13 over 2. The next step is to find half the coefficient of x squared. So we want to find half the coefficient of x squared. So half of that would be minus 1 all squared. And we have minus 13 over 2. So since we add half the coefficient of x all squared, we need to subtract it to keep the expression on this side balanced. So we need to subtract minus 1 all squared as well, because that's the only thing we add in the equation. So we subtract it to keep everything the same. And upon simplifying this part, we get 15 over 2. So we have this bracket here because it's really important that when we simplify this part, we need to multiply back it by 2. So that's the reason why we have this bracket there. So when we simplify this, we get 15 over 2. I can just work that out at the side here so you can see. So if we have minus 13 over 2 minus 1 squared, there it will be just 1. So to make the denominator the same, we just have 2 over 2, which is the same thing as 1. So you can see that it's minus 15 over 2 for that part. So now we have minus 15 over 2. But now we need to remultiply this part by 2, the 2 that we factor out. Okay, so what we have there is just minus 15 because that cancels out. So what we have there is just 2 into x minus 1 all squared minus 15, and that is now identical to what they asked you to write the expression as, the function as. So we have a into x plus h all squared plus k. So we have done part 1 there, and then we need to move to part 2, where it cuts the x-axis. Where it cuts the x-axis, f of x would equal to 0. So we need to make this equal 0. So we're going to have 2 into x plus 1, no, minus 1 all squared. Minus 1 all squared minus 15. We equate that to 0. So bear in mind this is part 1 that we have worked out, part 1. This is part 2, which is what they're asking you to do. Where it cuts the x-axis, f of x would equal to 0. So we just solve for x from here. So we would have 15 equals to 2 into x minus 1 all squared. We divide both sides by 2. So what we have there is x minus 1 all squared equals 15 over 2. Okay, and then we take the square root both sides for this. We multiply by a half. So what we have there is x minus 1. We multiply by the power half, if that's what, you know. So what we have there then would be the root of, plus or minus the root of 15 over 2. Okay, so then x would equal to plus or minus the root of 15 over 2 plus 1. And we're going to use our scientific calculator to get the value of x there. So we have 15 over 2 so what we get there is 2.7386. We're going to round it to 2 decimal places, so we get 2.74. So 2.74. So what we have there is x is equal to plus or minus 2.74 plus 1. So it means that we can have 2.74 plus 1, or we can have minus 2.74 plus 1. So we would have 3.74 for this one. Or minus 1.74. Okay, so we have found the values of x there. So that's x, and that's x as well. So we have found the two values for x. Now it says hence or otherwise we need to determine the interval when f of x is less than or equal to 0. So let's make a sketch of the graph so that you can understand what's going on there. Okay, so we're going to make a sketch of the graph there. So we have a point where we're making a sketch for, we're answering part 3. We're making a sketch of the function that is given. So we know that the function cuts the y-axis at -13. So we're going to mark this point on our sketch there, -13. Okay, and we know that from here, when this equals to 0, when x minus 1 equals 0, and we get x, that is the line of symmetry, and we know that this is the minimum, right? So that's the minimum, -15. So that's the lowest point on the curve. We know that the axis of symmetry is +1, and we know our minimum value. So if that's -13 there, cuts it there, -15 would be somewhere down here. So the lowest point on the graph is -15, and that's the minimum. So we can sketch our graph now. So we would have our curve looking like that. It's not the best one, but right, let's get off that. Okay, so our curve is looking something like that. Okay, now when f of x is less than or equal to 0, it means that we're talking about all the values below here, all the values in here, right? So it means that whatever value here at the x-axis, we know that it's 3.74, and we know that that's minus 1.74, so it means that x would be less than or equal to 3.74 and greater than or equal to minus 1.74. So okay, so the interval is given here. Okay, now part 4, the minimum value, part 4, minimum value of f of x would be -15, and part 5, the value of x for which it is minimum is 1, x equals 1. Okay, and here ends question 9.